Have you ever gazed up at the night sky, at those countless twinkling stars, and wondered what's out there? Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. That means even if we could travel at the speed of light, the fastest speed possible in the universe, it would still take us 4 years to get there, to reach the other side of our own Milky Way galaxy. That's a 100,000-year trip. Suddenly, the universe feels incredibly vast and we incredibly small. This cosmic speed limit, established by Einstein's theory of relativity, seems to be an unbreakable barrier. But what if it isn't? What if we could travel faster than light? Today we're rediving into one of the most exciting concepts in science fiction and theoretical physics. Could FTL travel ever be real? First, let's understand the problem. Why is the speed of light, or c, the ultimate speed limit? Albert Einstein, special theory of relativity, tells us that as an object with mass accelerates closer to the speed of light, its mass increases. This isn't just a theoretical idea. It's been proven in particle accelerators countless times. The closer you get to light speed, the more energy you need to go just a little bit faster to actually reach the speed of light. An object with mass would require an infinite amount of energy, which is, well, impossible. So, a head-on, brute force approach to breaking the light barrier is off the table. But physicists and dreamers are a clever bunch. If you can't break the rules, maybe you can bend them. This is where things get really interesting. Let's talk about wormholes. Officially known as Einstein-Rosen bridges, a wormhole is a theoretical shortcut through space-time. Imagine space-time is a giant sheet of paper. To get from one point to another, you'd have to travel across the surface. But what if you could fold that paper in half and punch a hole through it, connecting the 2 points directly? That's the basic idea behind a wormhole. You wouldn't be traveling faster than light within your local space. You'd just be taking a much shorter path through a higher dimension. It's like using a secret passage instead of walking all the way around the castle walls. Sounds amazing, right? Well, there are a few catches. First, we've never actually found a wormhole. They are purely mathematical predictions for now. Second, even if they exist, our current understanding suggests they would be incredibly unstable, collapsing in an instant. To keep one open, you need something called exotic matter, a hypothetical substance with negative mass and negative pressure. We have no idea if exotic matter can exist, let alone how to create or control it. So wormholes are a tantalizing but very distant possibility. But there's another, even more famous idea: the warp drive. Popularized by Star Trek, the concept of a warp drive is less about a shortcut and more about manipulating space-time itself. The most well-known theoretical model for this is the Alcubierre drive, proposed by physicist Miguel Alcubierre in 1994. Here is how it works. Imagine your spaceship is inside a bubble of flat, normal space-time. The Alcubierre drive would work by compressing the space-time in front of the ship and expanding the space-time behind it. Think of it like a surfer riding a wave. The surfer isn't swimming faster than the wave. They are being carried along by it. Similarly, the spaceship inside the warp bubble isn't actually moving through space at all. It's stationary within its bubble. But the bubble itself, this distortion in space-time, is moving, and theoretically it can move faster than light. Because the ship inside isn't technically moving, it doesn't violate Einstein's laws. You're not breaking the speed limit. You're moving the finish line closer to you. This is mind-bending stuff. But just like with wormholes, there's a huge hurdle. The Alcubierre drive also requires exotic matter, and not just a little bit. Early calculations suggested you need an amount of exotic matter with the mass-energy equivalent of the entire planet Jupiter to create a stable warp bubble. That's a pretty big energy bill. More recent research has brought that number down significantly, with some theoretical models suggesting it might be possible with just a few hundred kilograms of this strange stuff. But again, we're back to the same problem. We don't know if exotic matter is real. On top of that, there are other potential issues. Some physicists believe that creating a warp bubble would generate a massive blast of deadly radiation when it finally slows down, obliterating anything at its destination. Not exactly a friendly way to make first contact. So, where does that leave us? Both wormholes and warp drives, our two most promising candidates for FTL travel, rely on a form of matter that may not even exist. Does this mean humanity is forever trapped in our own solar system? Not necessarily. Science is a process of constant discovery. 150 years ago, the idea of flying in a metal tube across the ocean in a matter of hours would have been considered pure fantasy. Quantum mechanics, the very foundation of our modern technology, was once a bizarre and controversial theory. What seems impossible today might be tomorrow's breakthrough. Perhaps there are other principles of physics we haven't discovered yet. Maybe our understanding of space-time, gravity, and energy is still incomplete. There are theories involving quantum tunneling, where particles can spontaneously appear on the other side of a barrier, or the manipulation of extra dimensions proposed by string theory. These ideas are even more speculative, but they show that the quest for FTL travel is far from over. It pushes the boundaries of our knowledge and forces us to ask fundamental questions about the nature of reality. So, will our great-great-grandchildren be booking holiday trips to Alpha Centauri? It's impossible to say for sure. The challenges are enormous, perhaps the greatest engineering and scientific challenges humanity will ever face. It requires a substance we can't find and energy levels we can't comprehend. But looking up at that vast, star-filled darkness, it's hard not to feel a sense of hope and ambition. The desire to explore, to see what's over the next hill, is a fundamental part of who we are. For now, faster-than-light travel remains firmly in the realm of science fiction. But every new discovery, every new theory, is like a small step on a very, very long journey. And who knows? One day the fiction might just become science. What do you think? Is FTL travel an impossible dream, or is it an inevitable part of humanity's future? Let me know your thoughts down in the comments. Thanks so much for watching and for joining me on this cosmic journey. If you enjoyed this video and want to explore more of the universe's biggest questions, don't forget to hit that like button and subscribe to the channel. It really helps us out. Until next time, keep looking up.